Welcome to ClickMyProject.com. Let me discuss about the project optimal channel switching over Gaussian channels under average power and cost constraints. Let me discuss about the abstract of the project. The Gaussian channel is the most important continuous alphabet channel, modeling a wide range of communication channels. Optimal channel switching strategy is proposed with the presence of average power and cost constraints. Here there are channel switching is performed between single channel, two channel and three channels. Ratio of the power levels are dependent by the larger noise variance. Cost values are dependent to the average noise powers, so that average cost limit are easily specified between two channels. Error probabilities are estimated for logarithmic cost function, which are investigated as a function of power and cost. For optimal single channel strategy, only one channel is employed and channel switching is not allowed. For optimal channel switching strategy, more than one channel are employed, where the switching of channels are performed between two channels or among three channels. Derived generic cost function which provided optimal channel switching strategy is to switch among two most three different channels. Channel switching is not allowed for optimal single channel because only one channel is employed. Efficient channel switching strategy is performed at most three channels, which operates at the average power and average cost limits. In the case of channel switching between two channels, is proved that the ratio of the optimal power levels and the ratio of the noise variance estimated under certain conditions. The optimal power level is upper bounded by the noise variance to the smaller one. Under the same conditions, the error probability for convexity properties have been estimated based on the power and cost function. At last, the optimal channel switching strategy is obtained at most two channels. Let me discuss about the flow diagram for our process. First, initialize the parameter for performing the channel switching for among single channel, two channels and three channels. In the transmission over single channel, in this case one of the channel is employed exclusively. Based on this strategy cannot be an optimal solution of this unless there exists a channel with cost average cost. If there exists such a channel and I denotes the index of that channel, then the minimum average probability of error achieved, which corresponds to transmission over channel exclusively by utilizing the maximum available power. Note that this strategy may or may not be the optimal solution of the problem depending on the system parameter. Next, the channel switching between two channels. In this strategy, channel switching is performed between two different channels. It is observed from the average cost constraint that for the optimal channel switching between two channels, one of the channels should have a cost higher than average cost and the other channel should have a cost lower than average cost. Therefore, to obtain the optimal solution for strategy, kg is the number of channels the cost of which are lower or higher than AC. The error probability for many coherent modulation schemes can be represented either exactly or approximately. Next, in the case of three channels, channel switching performed among three channels. Let channel I, channel J and channel K denote those channels. Due to the strict average cost constraint, it is required that at least one of the channels must have a cost lower than average cost and at least one of the channels must have a cost higher than average cost. It can be obtained via optimization over a three-dimensional space instead of six by utilizing the three equality constraints. Therefore, to obtain the optimal channel switching solution, it can be necessary in general to solve the optimization problem. This strategy that achieves the smaller average probability of error becomes the optimal solution. Next, in the estimation of average probability of error, the average probability of error as a function of power and cost. Hence, a contradiction arises. Therefore, the strategy that switches among three channels can be optimal. In other words, for any strategy that switches among three channels, there exists a strategy that performs channel switching between two channels and achieves a smaller average probability of error. Finally, we calculated the performance. To investigate the effects of the average cost limit in more detail, average probability of error are plotted versus AC, that is average cost, for various areas of AP, that is average power, based on the same channel configuration as in the previous scenario. Both strategies achieve an average probability of error that is equal to the error probability of the best channel at the power limit. Let me discuss about the running procedure for our process. Select the main 1.m file in the current folder, right-click the file and run for executing this process. This is the main window for optical channel switching over Gaussian channels under average power and cost constraint. Select the channels. For a single channel, transmitter and receiver are connected via a single channel. For two-channel communication, transmitter and receiver connected via two type of channels. For three-channel communication, transmitter and receiver connected via three channels. For four-channel, transmitter and receiver connected via four channel. For five-channel communication, transmitter and receiver connected via five different channels. By pressing the channel switching button, we can perform the channel switching operation. This is the main two window for optimal channel switching over Gaussian channels and average power and cost constraints. Here select channel switching operation for single channel, two channel and three channels. By pressing the single channel, we have to select any one average power limit. Select any one average power limit among these values. Here performing the channel switching operation via second channel, and here I display the power and channel switching factor for a single channel. And now here we change another type of average power limit. Here performing the channel switching operation via second channel. Here now the process will be performed via fourth channel, and we got the average power and also channel switching factor. And now by pressing the two channels, we can perform the channel switching between two channels. Here select any one average power limit for two channel communication. Now second and fourth channel will be performed channel switching operation. We got the power and the channel switching factor for two channels. Now changing the value for power limit for second two channels communication. Here performing the operation for third and fourth channel, we got the power and channel switching factor. Now performing three channels communication. Here we have to select average power limit. The average power limit is 0.05, and by pressing the 0.05 we perform the channel switching operation via first, second and fifth channel. We got the power and channel switching factor. Now by pressing the performance analysis button, we can perform the analysis process. By pressing the average cost as select any one average cost. Now by pressing the average cost as 2, then we got the average probability of error versus average power for average cost equal to 2. Here we got the output for optimal channel switching as well as optimal single channel, and here we got the number of channel performing this process is 4, and the noise variance and also the cost of the channel, that is average cost. Now by changing the average cost as 5, we got the output as average probability of error values versus AP for AC is equal to 5, and here the closed loop for this graph will be obtained, and this is the average probability of error versus various average cost limit when k equal to number of channel is 4, and this is the noise variance and the cost of the channel when average cost will be 5. Now changing the average cost as 0.9, we got the average probability of error versus AP for AC is equal to 0.9, and also got the graph for average probability of error versus various average cost limit for different AP, and here the K equal to 5, and we got the noise variance and cost of the channel. For here the number of channel will be performed, 5 channels will be performed. Finally, the convexity properties of the error probability are investigated for logarithmic cost function under power and cost constraints. Thank you.